All right. So, remember I gave you yesterday the green sheet, and I told you at the back of the green sheet there's important numbers that you're going to have to kind of like remember. And then remember I told you when you do them, look at these numbers, like 1 squared is 1, 2 squared is 4, 3 squared is 9, right? And then 4 squared is 16, and so on and so forth. I told you when you see these numbers, you need to be able to identify them. So when I see 1, 4, 9, 16, stop talking, 25, 36, all of these, you need to be able to realize these numbers. You need to be able to understand these numbers. We call these numbers square numbers. Okay? So a number is a perfect square. We call them perfect. If when you square root it, it's going to give you a whole number. Okay? So if you go back to these numbers that you found yesterday, right? And if you had 4, and then you square root 4, you're going to get 2. If you had 121, and you square root that, what do you get? 11, right? So, for example, if I have 115, and I square root it, do I get a whole number? No, I'm going to get a decimal. So this is not a perfect square. Okay? So the perfect square are the numbers that when you square root them, it's going to give you a whole number. You need to be able to realize that, and you need to be able to see them. Okay? Now, with respect to the numbers, it's easy. They're easy to identify. If you square root, you know. Now, how about the letter? How can I know if a letter is actually a perfect square? A letter would be a perfect square if the exponent is an even exponent. Okay? So an example would be x to the power of 6. Or if you have y to the power of 10. Or if you have m to the power of 8. All of these are perfect squares because their exponent is even exponent. Okay? So not only that you're looking for the number in front, the coefficient, but you're also looking for the exponent on the left. So for example, can you tell me if this is a perfect square? Yes, because? Okay, so 25 is a perfect square, and x to the power of 4 has an even exponent, so it is. Okay? Is this term, for example, a perfect square? What's square root of 8? Is it a whole number? It's 2 point something, right? Square root of 8 is not a whole number. So is this a perfect square? No, it is not. Okay? How about this? Is this a perfect square? Why not? The exponent is not even, right? My exponent here is 1, right? So my exponent is not even. Yes, the 100 is a square root because I can square root 100, but then x does not have an even exponent. So this is not a perfect square. Okay? So you need to be able to look at the term, and you need to be able to know if it's perfect square or not. Now, why do we need to understand that, and why do we need to know that? Because there is a special factoring technique, what we call difference of squares. It's a special factoring technique. If you guys are not awake right now, I need you to be awake. So, you are looking at what we call difference of squares. What does the word difference mean? Subtraction. So if I have two square terms and I'm subtracting them, there is a special factoring technique. And let's see how do I do that. So, I'm looking at this binomial. It has to be a binomial because I'm looking at two terms only, with a minus between them. So, I have a binomial here, 9x squared minus 16. Can you tell me if 9x squared is a squared term? Yes, it is, because 9 is a squared term, right? Because square root of 9 is what? 3. And x squared has a even exponent. Okay? Is 16 a perfect square? What's square root of 16? 4. Good. So I have two, both terms are perfect square, yes? Can I check mark that? All right. Do I have a subtraction between the two terms?
Yes.
Good. Then if both of these rules are a check mark, then I can follow the following. Here's how I factor this. I'm going to show you the different steps, but then technically speaking, at the end, we're going to do it all in one step, okay? So, to set this up, to factor this, you're going to set up two brackets. In the first bracket, you're going to put a plus in the middle, and in the second bracket, you're going to put a minus in the middle. Then you're going to square root the first term and place it in each bracket in the first position. So you're going to square root the first term and put it in the first position. Okay? So square root of 9x squared. Again, right now it's going to look like I'm doing multiple steps, but technically speaking, I will write it as one step usually. And then you're going to square root the second term and put it in the second position. So you're going to square root the 16 and put it in the second position. Now, what's square root of 9x squared? 3x. What's the square root of 16? 4. So I'm going to end up with 3x plus 4 and 3x minus 4, and this is my factoring. Remember that factoring, you have two things multiplied together. Two brackets multiplied together. Okay? How can I tell if this is correct, if this is right? What can I do to confirm my work, if I want to confirm? FOIL it, right? So if you want, well, you know what? I'm not 100% sure if I've done this right? On the side, you can do this. Okay, let's see. 3x times 3x minus 4, right? And then, okay, let's FOIL this. So that's 9x squared minus 12x plus 12x minus 16. And that's going to be minus 12x plus 12x. They cancel each other. So I'm left with 9x squared minus 16. Boom. Right? This is just to check your work, if you're not sure about it, or if you want to double check your work. I don't want to see this on your test. If you want to check your work, you check it on a separate piece of paper. Okay? Do we understand this? So, we're looking for two terms. It has to be a binomial. They have to be square terms, and there has to be a negative in between. We call this what? Difference of squares. Okay. Two square terms?
So it's going to be x minus 5 x
Two square terms?
x X plus.
Okay, I'm asking you, is it 2 square terms? Yes. Do I have a minus in between the 2 terms?
Yes.
Good. So I can use difference of squares. So I'm going to skip all the steps. And I'm going to, okay, in my head, what's square root of x squared? X. What's the square root of 25? And they go like this, and I'm done. Yes.
Can you put 1x
Doesn't matter. Nope.
So you just square root.
You can do the square root of 25 on there. No. Sorry? Okay, here's the thing. With letters, how do you know what's the square root of x squared? So, here's the rule. I'm just going to go back here. So, when you're square rooting a letter, right, to find the square root of that, you're going to divide the exponent by 2. Which means, if I have the square root of x to the power of 8, that's going to be x to the power of 4 because I'm dividing 8 by 2. What's the square root of x to the power of 10? X to the power of 5. What's the square root of x to the power of 6? X to the power of 3. Okay, so you know that it has to be even exponent, right? And then when you square root it, you're going to have to remember you're dividing the exponent by 2. Are we okay with that?
2 divided by 2 would just be
1, and that's why I end up with a 1. Yeah, that's right. So 2 divided by 2, that's 1. That's why I just end up with an x. Okay, let's do that one. Do I have 2 terms that are perfect squares? Yes. 16x squared, 1y squared. 1, remember, a lot of people forget that 1 squared is 1, right? Do I have a minus between them?
Yes.
Okay. Let's do it. What's the first step? 2 brackets. Put a plus in the middle of the first, minus in the middle of the second. Square root of 16x squared.
4x.
I put it in for first position. Square root of 1y squared.
Y.
Just y. You can write 1y if you want. It's the same thing. Okay? Remember, 1y and y is the same thing. How about the next one? This is it. This is difference of squares. That's it. That's all you have to do.
Are you sure?
I am positive.
Usually there's a
Absolutely.
catch.
No, not yet.
Yeah.
We're kidding.
Yeah.
Okay, when we do combos, right? When we do combination of different factors. Okay, how about this one? 2 squared terms, 2 brackets. Mm-hmm. 9x. 2y squared. Okay. All right, now you can do the second part of your homework, the bottom page. Okay, I'll maybe give you just about 5 minutes to try a couple questions because I would like to go to the next lesson. Okay, we're going to learn a lot of factoring today. I know, me too. Yes.